Good afternoon. Welcome to session 4A on machine learning and natural language processing. Let me introduce you to the session chair, Dr. L. Ranatunga. Dr. Ranatunga is a senior lecturer from the Department of IT, University of Morocco. He is a council member of Sri Lanka Association of Advancement of Science, treasurer of IEEE Computer Society Sri Lanka chapter,
Recording in progress.
coordinator of Social Media Analytics Research Group of the University of Morocco. He received the BSc Special Honours degree from the University of Peradeniya, Sri Lanka, and the Masters in Computer Science from the University of Colombo. He received the Postgraduate Diploma in Distance Education degree from the Indira Gandhi National Open University, India. He obtained the PhD from University of Malaysia, and he has been working at the Faculty of Information Technology, University of Morocco, Sri Lanka since 2004. Dr. Ranatunga has worked as the head of the Department of Information Technology, University of Morocco from 2012 to 2018. His research interests focus on multimedia information processing, more towards video content description, reduction of visual feature space, semantic video scene indexing, and retrieval. He has published articles and he is a designated reviewer of number of international journals and conferences. Dr. Ranatunga, I invite you to lead the session from here onwards. Thank you.
Thank you, Yasodhara, for the kind introduction. And for the today's lineup, we have 5 presentations. So all the five presenters may be available here within this particular session. And those are paper ID 70, paper ID 214, and paper ID 186, paper ID 192, and the last one is paper ID 152. So in the lineup, the first to go is the presenters who are coming from paper ID 70. So the title of the paper is Microeconomics Event-Based Expert Advisor for Forex Trades through Algo Trading. So this presentation is to be done by 3 presenters: the H.J. Vanniyarachchi, R.M.S.J. Ratnayaka, S.G. Ishara. So all 3 are from University of Morocco Faculty of IT, and they are all 3 are undergraduates, and they are leading to one of the degree BSc Honours in Information Technology and Management. So let me call upon the presenters from paper ID 70, Microeconomic Events-Based Expert Advisor for Forex Trades through Algo Trading. So at the beginning, I want to tell you that each and every presentation will followed up with the Q&A session, 5 minutes Q&A session. So you have to be there for your Q&A session. We will we want to in advance tell that all the time after the presentation, all the people have to be there for the Q&A session. Thank you. You can start the presentation, paper ID 70. Hello, still that presentation is not started. Is there a technical problem?
Macroeconomic event-based expert advisor for Forex trade through Algo Trading. This project was conducted as a research-based group project under the supervision of University of Morocco Faculty of IT. This is how we align the content. We'll move one by one. We move to the introduction. Forex. Forex stands for the Forex Exchange, where participants can buy, sell, exchange, and speculate on currencies. This currency market is considered to be the world's largest and most liquid market with trillions of dollars shifting in hands daily. When it comes to the forex market, risk is a very critical issue due to frequently fluctuations in currencies. Forex investors make their investment decision based on two types of analysis, which are technical analysis and fundamental analysis. But many publications shows that many long-term traders are doing better, but the new traders are only engaged in day trading with perception of minimizing the risk with their knowledge and take advantage of short-term fluctuation in an asset price. Further, De Rodrigo says that even more than 80% of forex day traders lose their money and ending up quieting the market at beginning of their journey. Less knowledge in market events and only rely on the technical analysis are main reason for short-term investors leave their market sooner. Actually, forex market technical analysis cannot trigger very abrupt market movement in the events. Only consider the historical behavior on currencies based on the moving average like kind of techniques that are not concerned about the events happen in the market. But when it comes to the fundamental analysis, they do care on the forex market event, but unfortunately existing indicators are incomplete due to that concern only limited aspect of external economic factors. Further, there are no demonstration based on the active hour-based prediction in existing indicators. The aim of this project is to design an economic event-based indicator to identify the patterns and provide signal-based fundamental analysis to make profitable day traders in the forex market. Main objectives are identify the strength of influence among the macroeconomic events and the market currency pair, and identify the correlation among currency pairs and calculate their strength. Also going to introduce market active hour-based indicator as a novel approach and generate market price direction signal and visualize graphically. Under the related work section, the research forecast forex with ANM using fundamental data has used quarterly based economic event like interest rate, GDP, quarterly trade balance and CPI as input parameters. Moreover, to improve their speed of trading, they have introduced new algorithm. Next, an adaptive orders fuzzy time series with application of forex. This has applied the forex time series data such as support vector machine and fuzzology. But one of the limitations of this research is that monthly prediction did not give a satisfactory level of result due to the few data samples. Further, forex trend classification using machine learning technique based on supervised machine learning classification are known as radial basis functional neural network, multi-layer perceptual neural network, and support vector machine. But this project was conducted only based on the technical analysis. With considering the problems and limitations in literature and the forex market, our solution was to develop macroeconomic event-based expert advisor for forex day traders who have a lack of knowledge on forex market. This expert advisor will do the day trading without any human involvement based on the trading algorithm which we built as the research. For that, we considered 7 most influential macroeconomic events based on the literature, which are CPI, payroll, PPI, interest rate, unemployment, GDP, and retail sales, and provide the advice on AUD USD, Euro Swiss franc, and USD Japanese yen currency pairs. Our approach consists with 3 models. First, we analyze the trend in selected currency based on the macroeconomic event releases and analyze the correlation strength in between currency pairs. As a final model, we develop the signal algorithm to detect the trend and strength and visualize the trend direction. High-level architecture. Our high-level architecture consists with the 5 layers as you can see here. In the data source layer, we used macroeconomic data and forex currency data. Also, we gathered real-time online data event streaming through external APIs, and then we captured the events. In data processing layer, we processed our data and clustered. In strength calculation layer, we identified the how different event can affect the based currency pair and identify the impact of economic factors to non-relevant currency pairs. After that, in analytical platform, we predict the currency pair trend and strength and do the calibration. Finally, in data presentation layer, we visualize the result. Our data sets. The event data set represents all the releases from year 2011 January to 2020 August. Also the historical currency data captured and gathered with frequency of 15 minutes from year 2000 to 2020 that are gathered from online financial vendor known as Oranda. Data preprocessing. Since the historical data is represented as a time series value and it was easy for manipulation, but as the two data sets were represent two different time zones, so we convert the time frame into same. Also, we use min-max scale normalization method for non-categorical variable and conducted one-hot encoding for the categorical feature data. Our methodology of the research implementation. First, we move to the trend analysis based on macroeconomic events. Here we focus on how different events can affect the currency market and in turns. For example, assume GDP release has happened in Australian market. This analysis shows how that event affect to Australian dollar and US dollar currency pair in terms of trend, whether it's upward or downward, and in terms of time duration of the effect. This explains how we consider relevant and non-relevant currency pairs. For example, any event happened that related to Australian currency, the relevant currency pairs will be Australian dollar and the USD. Non-relevant currency pairs will be Euro and Swiss franc and the USD Japanese yen. Also, when it comes to the any event happened that related to USD currency, the relevant currency pairs will be USD and Australian dollar and the USD and Japanese yen. But non-relevant currency pairs will be Euro and Swiss franc. Analysis and design of trend analysis. To the implementation of trend analysis, we use three supervised learning classification, which are random forest, K-nearest neighbor, and SVM, to come up with the most suitable technique to trend analysis. Also, by introducing random forest into Forex fundamental analysis, we address the gap in literature. Moreover, the linear regression was used to identify the strength of the event. Major point is we use candlestick parameters such as high, low, open, close, WIP values to build the trend analysis algorithm without using moving average kind of technical analysis. Simply here we use the concept of volatility based average directional movement index to get the behavior of the trend. To identify the effect from an event on the non-relevant currency pairs, we conducted correlation extraction method and used regression mechanisms. Built-in trading algorithm. The trend results based on the non-relevant currency pairs and the relevant currency pairs are taken as input for this model. And this mathematical model consists with two major models, which are price action model and the confirmation model, where we considered forex market volume and the active hours. Also, we assign weight for each model. The optimal value calculated through the artificial neural network. The backtest propagation and the calibration was conducted to optimize the results. Also, we use real-time trading with both demo and real accounts. Price action model was the major tuning point of this research project. We designed algorithm to each and every action of behavior of candlestick parameters, like you can see in these patterns. For that, meta code was used to conduct the algo fixing part. Confirmation model is submodule of the price action model. This module was designed with the encounting of the active hour and the volume data. This confirmation model confirms the price action model results with the volume data. After all model building purpose, we have assigned optimal and most profitable values for the model. For that, we have used artificial neural network. To evaluate the trade algorithm we built, we conducted backtest and calibrate all the values with using MetaTrader strategic tester. Finally, we test our research algorithm with real trading account, and real money, with link in the MQL5 community, which is the one of most trusted community of measuring the traders' performance. So according to their statistic result, we capable to make 1.16 profitable factor level. That shows good sign of the profitability. When we talk about the evaluation of trend analysis, you can see that KNN gives slightly best accuracy on all the three currency pairs on every considered time frames. Also based on the test result of research conducted for Forex daily trend prediction on USD and Japanese yen currency pair, the accuracy was 72% on the SVM classification. But here we are able to achieve 75% of accuracy level. Limitation. Our main limitations are we cannot measure the trader's psychological effect. Also, we cannot consider all the unexpected macroeconomic announcements. As a further work, we are hoping to develop a fully automated Forex robot. Conclusion. When it's come to the conclusion of our research findings, we can say that most of the recent research on the Forex market has provided a more understanding of the technical analysis. But fundamental analysis is kind of an investment filler. A proper understanding of fundamental analysis of the economic announcement, macroeconomic events will allow traders to lay a strong foundation for the investment decision and build a profitable trader. Thank you. Here we have attached previously created demonstration video to more clarification of our research results.
Okay, so that's the presentation, and thank you very much for that presentation. And can we have the authors and their representatives? Okay, there is one. Yeah, Ishar Tilina is there, and okay. Now the floor is open for few questions. So if there are any questions, you can raise those questions now. Okay, Ishara, what I want to clarify is that now when you are feeding the data, you have selected the 2011 to 2020, the currency, the events, currency fluctuations, and those events are already recorded. And also you are feeding the news events, right? So macroeconomic news events also we are going to feed. Now, when you are feeding this macroeconomic news events, have you scaled it or maybe translated into some kind of a numerical form, or have you used that news event as it is as a kind of a, language expressions?
Actually, one skill we get from investing.com, actually this data set couldn't get from investing.com. When release the data event, investing.com, they scale this event. It is more important or moderate important or low important. We scale got to our measurement.
So those are in the three ranges, right?
Yeah, three ranges. It's a basic level scale.
So that means that with respect to the financial gain or loss, that is the way they have represented, right?
Yeah, it can be financial loss. So
but now in this those three scales, that is not for the direction of the positive or negative.
Yeah.
So the direction is also not represented, but the important, not important, that those are the things given, right? That means the relation related or not, right? The polarity is not there, right?
Yeah. At that point, we only get fluctuation level. That can be on direction up or direction down. After that, we capture the proper upward and down direction. It's have other mean we calculate current price movement and current market behavior using current price data, current volume data, current data. All those data final result become we can predict this go into up direction or down, but we cannot detect within that scale that go to up level or down level.
Okay, thank you. So any other questions? Okay, so that seems there are no any other questions. So let me take this opportunity to thank and congratulate the research team with Ishara for their achievements and the presentations. And so we can move to, thank you Ishara, and we can move to the next presentation.
Thank you very much for this opportunity.
We can move to the next presentation. That is the paper ID 214. The presentation is titled as Mammogram-based cancer detection using deep convolutional neural network. This paper will be presented by Hasini Rangika Thudaveheva. So she has she's a fourth year undergraduate at Sri Lanka Institute of Information Technology, following BSc Honours in Information Technology, specialization in Information Technology. So she has gone through a full stack software development training at the University of Ruhuna. She is interested in image processing, machine learning, and deep learning areas. So Rangika, the floor is open for you to present your paper.
Hi everyone, I'm Hasini Thudaveheva. My research part is mammogram-based cancer detection using deep convolutional neural network. In my background, breast cancer gets the main place among the non-communicable diseases. The terms of the breast cancer mean a malignant tumor that develops from the breast tissue. The mammogram is the most effective way of identifying the abnormalities in the breast. Doctors can make a good, highly accurate decision using the mammogram. The time will be saved for both patients and radiologists. In this proposed system, patient can get the report according to their mammogram. This report reveals out the types of the tumor, benign or malignant, size of the tumor, location of the tumor, and state of the nipple. It is abnormal or not. These are my research questions. Mammogram cannot be read by everyone. It can be read by only the radiologist. Manually, mammography reading takes a long time. In manual method, sometimes mistakes are possible. In the manual method, mammogram images cannot be enlarged, and therefore, radiologists find it hard to explore them further to get more details. In manual method, patients have to wait for a long time to get the results of the scan report. Therefore, patients have faced so many difficulties. This is my research gap. There are many research that have been available in this area. Now I hope to compare my research gap using these 4 researchers only. This is my research gap table. Provide the tumor size by analyzing the mammogram image. Provide the lump location where it has been in the breast tissue. The state of the nipple is given, normal or not. Suggest the more testing methods according to the mammogram. Use sequential model. These features are covered from my proposed system. These are my specific and sub-objectives. Sequential model will be used to detect the mammogram images. Implement a user-friendly web interface to upload the mammogram. Mammogram images will be both detected and analyzed. The system will be generate a report according to the mammogram images. The system will suggest more testing methods based on the generated report. Then moving on to the methodology. First one, gather the mammogram images. In here, I have already gathered the mammogram images using MIS, DDMS, and InBreast databases. These databases include more than 1,000 mammogram images. In pre-processing step, I firstly resize the mammogram images dataset. Then I apply filtering methods. Mean, median, and Gaussian filter were I applied. I can identify Gaussian filter is the best one. Then divided dataset into the two sets as a training test and testing test. Testing data help to validate the model. Then apply sequential model to build the model. This sequential model help to build the model layers by layers. I especially use softmax and ReLU function to define the layers. This ReLU function help to get good accuracy. These ReLU functions active only the important neuron in each layer. As well as softmax functions give the output as the probability like normal, malignant, or benign. In feature extraction step, I extract the features in each layer. I can identify total number of features which I can train. Then train the model and predict the results. After that, generate a report according to the results. This report include the state of the nipple, state of the breast, and other necessary details. Finally, suggest more testing methods according to their generated report. This is my system diagram. In server side, upload the mammogram image to the system, then apply filtering methods and divided dataset into the two sets as the training set and testing set. In sequence, apply then apply the sequential model and extract the features and train the model. Get the outputs as the normal and abnormal. When mammogram is abnormal, generate the report according to their mammogram. In client side, user can upload their mammogram image to the system and get the output according to their mammogram and download the system generate report. This is my techniques and technology which I have used. This is my requirements. System requirements are the proposed system works on the Windows, Mac, and Linux OS. The system will give a proper instruction to get the report of the mammogram. Personal requirements are user should register to the system. Privacy is protected. No privacy data will be gathered by the system. Patients, radiologists, and doctors are the actors who use the proposed system mainly. Software specification requirements are works with any web browsers, access at anywhere, anytime, easily used by anyone. User access to this website any devices. Completions of the project. Mammogram detection done with two subparts. First part is breast classification. Dataset size of the breast classification is more than 500. In breast classification, I identify the state of the tumor. It is normal or malignant or benign. Analyze the location of the tumor. Analyze the tumor size. In nipple classification part, I have used more than 500 images for nipple classification part. In nipple classification part, identify the state of the nipple, it is abnormal or not. A change of the nipple may be a basic symptom of the breast cancer. Therefore, it is important to know the state of the nipple. Then generate a mammogram report according to the above results. In breast classification part, I apply medium and Gaussian filters. I can identify Gaussian filter is the best one. This is the sample size of the breast classification part. In here, divided data set into the two sets as a training data and testing data. Build the model using the sequential model. Use ReLU and softmax activation function to define the layers. 4 main layers were used. The first 3 main layers were used ReLU function. The last main layer were used softmax function. Build the model with the training data set which have 15 batch size and 20 epochs. Validate the model using the testing data. This is the model accuracy according to my breast classification part. The size of the tumor and located place of the tumor are identified. In here, I applied 2 methods, but I can identify method 2 is the best one. In method 2, apply a Gaussian blur to image and then find the brightest location of the tumor. Firstly, I converted mammogram image into the grayscale image. Then find out the maximum value and minimum value of the brightest location. Then copy the original image and cover the tumor location. Then results given as follow. Then measure the size also. In nipple classification part, I apply medium, mean, and Gaussian filtering. Then I can identify Gaussian filter give a good performance. This is the sample size of the nipple classification part. In here, divided data set into the 2 sets as a training data and testing data. Build another sequential model to the nipple classification part. Use ReLU and softmax activation function to define the layers. 3 main layers were included. The first layer used the ReLU function. The last layer was used the softmax function. Build the model with the training data set which has 20 epochs. Validate the model using the testing data. This is my model accuracy according to my nipple classification part. This is my user interface. And this is my generated mammogram report. In here include all details according to their mammogram. When state of the breast is abnormal, systems recommended the medical treatments for patient. These are my references, and thank you very much.
Okay, thank you very much, Hasini, for your nice presentation and already recorded presentation. And Hasini, are you there? Okay, she's here.
Yes, sir.
And now the floor is open for a few questions. If you have any questions, please ask those questions now. Okay, Hasini, as still no one is raising any questions, let me ask you one question, because when you are doing this particular study, there are 2 things you have covered. One is that nipple classification, and also the other one is the breast cancer detection, or the malignant or the benign. So you have taken the 3 states of that particular cancer detection, and the nipple classification, what are the classification categories you have? Hasini?
Yes, sir. In nipple classification, I category. Sir, can you hear me?
Yeah, now we can hear.
Yeah. So in nipple classification, I category to the nipple into normal or malignant. This is A change of the nipple may be a basic symptom of the breast cancer. Therefore, it is important to know of the state of the nipple. I categorize these nipple into it is normal or malignant. When it is the abnormal, this mammogram has some issues. That's also.
So then when you are categorizing the mammogram based that breast cancer, you are using the contrast, right?
Yes.
After converting into the rays, you are taking the contrast and the brightest location you are spotting out.
Yes, sir.
Right? So what is the radius you are taking when you get a brightest location?
I contrast the image to grayscale image and extract the minimum and maximum value of the brightest location. It is help to me to get the tumor location in the breast, and I analyze the size using the another function and extract that source.
So the radius, so you have not fixed value that you are calculating time to time in different manner.
It is not a fixed value. It is depends on the tumor size.
Right. So ultimately, the final result will be given by using both the detection and the nipple detection. Now you have to identify the nipple automatically. Now, how did you calibrate that one? Detection of the nipple.
In front-end, user can upload their mammogram image. In image also have image of the nipple. It must be to detect the nipple also. We user upload their mammogram image with the nipple. In system give the status of the nipple according to their mammogram image.
No, my question is how to localize the nipple. If in the image you have to identify the location.
Yes, sir. In system, extract the location of the nipple. Extract only the system crop the nipple of the image and detect that it is abnormal or not, and give the results to the customer.
Okay, right. Okay, so thank you, Hasini, for your presentation and the this particular contribution what you have done in this area. So let I take this opportunity to congratulate Hasini and her team for their contribution. And so thank you, Hasini. And
thank you, sir.
So we are going to move to the next presentation now. And our next presentation is related to the paper ID 186. And that presentation is titled as EEG-based real-time system for video advertisement recommendation. There are 5 presenters contributing to this particular presentation. KR Soumya Kumari Bandar, Satsarani Kavindika Bandar, Soumya K. Bandar, and Uvini Vijay Singh, Bandar P. Jayalath. So those are the 5 presenters who are contributing for this particular presentation. And all these 5 presenters are from Sri Lanka Institute of Information Technology. So the first 2 presenters and last 2 presenters are undergraduates of the Sri Lanka Institute of Information Technology, and the third presenter is working as an assistant data engineer attached to Enable Colombo. That is a kind of a company. He's working as a kind of a data engineer. So presenters, you can start your presentation now.
Good day, everyone. The solution that we are going to propose is a real-time video advertisement evaluation and recommendation system, which is based on EEG brain signals. This is the research team. Starting off with the introduction. Video advertisements have become increasingly popular over the recent past years. Eventually, they have become the most popular medium of bringing products to their customers, and it has led to a crucial state where people had to assess the effect of the commercials. Due to the low effectiveness and unreliability of current video ad evaluation methods, there created a huge demand for a video evaluation system to overcome the conventional user rating issues. The industry is currently using pre-test and post-test methods to evaluate advertisement. These methods have flaws where might get in biased reviews as well as inaccurate results. So we have come up with a solution where the main objective is to analyze brain waves and build a real-time system which can evaluate video advertisement and provide recommendation based on the EEG performance of the audience. This approach has more accurate and trustworthy results because this system is based on human brain waves. So, why the proposed system is so important? Firstly, it is a novel method that can check the quality of an advertisement. Then it is capable of evaluating video advertisement based on the emotion, tension, and enjoyment of the particular user in real time along with recommendation. So, moving on to the background study and the literature survey. So, as I mentioned before, the current approaches for video advertising in the business rely heavily on indicators via the pre-test methods and post-test methods. So, pre-test methods are getting paid reviews from the industry specialists, conducting surveys with the sample audience, and the post-test methods of getting like counts, view counts, and review comments. So, because their reviews might be biased and the score is subjective, this does not always result in proper replies. This type of data collection and analysis will lead to incorrect conclusions. So this suggested technique would analyze a user's likeliness to a certain movie trailer using EEG brain signals collected from the same viewer. When analyzing past research done, it can be clearly seen that there is a gap between the existing methods of video advertising, which is a real-time evaluator from attention, emotion, and enjoyment aspects of the viewer, along with the recommendation and rapid feedback regarding the movie advertisements. So the below table shows the comprehensive comparison between the existing system and the proposed system. So moving on to the overall system architecture, basically the collected brain signals will evaluate through an emotion, attention, and enjoyment analysis. The collected data under a controlled environment will be used in machine learning prediction models after verifying a preprocessing and a feature extraction. So then there will be calculated an emotion, attention, and enjoyment scores, which will be passed to the recommendation model. Then the final solution will be able to evaluate an advertisement from emotion, attention, and enjoyment aspects along with the recommendation. So in order to do that, we use a brain sensing headband called Muse2 to capture brain waves as EEG signals. So the sensor has 4 channels placed behind the left and right ears and on the forehead. So Muse2 captures signals of delta, theta, beta, alpha, and gamma frequencies. Also, the headband will connect it to the Mind Monitor mobile app via Bluetooth, where it generates a CSV file consisting of these EEGs.
This study has carried out 4 main areas. Evaluate movie advertisement based on the attention oscillation levels of the spectators. Evaluate movie advertisement based on the emotion of the audience. Evaluate advertisement based on the entertainment occurs inside the audience. At last, recommendation system based on attention, emotion, and enjoyment. This section illustrates the research methodology. First, let's brief the attention analysis methodology. After capturing EEG data, extracted 39 features via feature selection process, only 18 features were selected using linear discrimination analysis and Pearson correlation coefficient methods. At the beginning, for the model building process, this study is using several machine learning and deep learning algorithms. The input data were aligned to treat attention levels as high attentive, medium attentive, and low attentive. As machine learning-based models use KNN, SVM-based classifier, SVC, random forest, decision tree, and extra tree classifier models. And also as deep learning based models, multi-class LSTM model with transfer learning technique was applied. For evaluating the model performance, use precision, recall, F1 score, macro average, and accuracy. After building successful model to classify data, the next step was to implement a function for generating an overall average attention score based on both video and the viewer. Eventually, the final average attention score is sent to the recommendation system. After collecting the dataset for training models, the quantitative view of tree levels is appear in the figure 1. The feature selection can be seen in figure 2. This table has included the matrix value for used machine learning models. As you can see here, CSV model has the best performance. CSV means this uses the C regularization parameter to optimize the margin in hyperlane. In this study, use RVF function for multi-class classification problem that is well suitable. When it's come to the emotion analysis methodology, the captured EEG data was pre-processed to a final data set was created by combining different CSV generated for each emotion category while the user was watching happy, sad, satisfied, and neutral types of videos. After some pre-processing steps like removing the noise data, jaw blinking, eye blinking, null values, removing unnecessary columns, that clean dataset was sent to the feature extraction. It has implemented 4 methods of feature selection such as Pearson correlation matrix, XGP classifier, recursive feature elimination, univariate selection, which was later removed because it was not applicable due to there are non-negative values. The results of the conducted experiments are visualized in this page. After pre-processing and data extraction, the clean dataset was sent to the model building for emotion classification. Then, the chosen best predicted algorithm was evaluated using scoring model. Then, they are implemented a final emotion score, which would be sent to the recommendation model via an API. Finally, emotion variations during the video runtime were visualized in the user. As explained before, 3 predicted algorithms of random forest gradient boost and extreme gradient boost algorithms were used and evaluated using several matrices, and the results are displayed in this table. Models were evaluated using precision, recall, F1 score, and accuracy. As you can see, since random forest algorithms give the best accuracy of 92%, it was taken as final algorithm of prediction. When it's come to the enjoyment methodology, first EEG data was gathered while participant was watch a trailer that is personally attacked. Those data are pre-processed, removing noise and artifacts. After feature selection, statistical analysis and evaluation have been done using confusion matrix. At last, we to an API that connects to the main system. The experiment gives a vast approach in statistical method by standardized data and dimension are reduced using principal component analysis in identifying highest correlated attributes are gamma and beta. This spotted that each beta and gamma readings from 4 epochs distributed the same pattern. Then acquired beta and gamma samples separately and applied Shapiro-Wilk test. Here, p-value is less than 0.05. For both gamma and beta, hence data is not normally distributed. Here is a perfect situation where we can apply control limit theorem. The sampling distribution of sample means are symmetrically around the population mean. Afterwards, empirical rule has been applied. This rule states that if the data is normally distributed, 68, 95, and 99 data will fall within the range of lines indicating region represent strong enjoyment and rest of the data is considered as not enjoyed. These are identified ranges and will calculate overall score using this matrix. Recommendation methodology consists of several steps. Firstly, recommendation system was trained using movie data and scoring data. The model inputs are attention, emotion, and enjoyment scores taken from users. And these user inputs are connected to the recommendation models. To build the recommendation system, the study used 4 types of models, which were collaborative filtering, content-based filtering, hybrid approach, and restricted Boltzmann machine. Once the models are used, each of them were evaluated using mean absolute error, root mean squared error, hit rate, coverage, and diversity. Finally, recommendation output was connected to the interface using an API.
Here onwards, I will be briefly explain the backend evaluation we used in this study. After generating the scores for each level of attention, it is important to test the result with actual users and verify whether the system is actually producing more realistic results. The test involved a total of 10 people who were chosen for the attention analysis. They were given video advertisements and asked their manual feedback on how focused they were. Then system output for attention analysis compared with actual user feedbacks. The given table, the sample of composition is shown, and according to the emotion-based video advertisement analysis, after building prediction model, it is important to test the result with actual users and verify whether the prediction model is actually predicting more realistic results. Thereby, the test was conducted by selecting 10 volunteer participants, and they were given advertisements and asked to provide a score for 1 to 5 scale after watching the video. That value was compared with predicted emotion score. The average value of participant scores and predicted scores are listed in this table. And 80 of test results came positive. Here, in the same way, for the evaluation related to enjoyment have been done by selecting 10 participants. Advertisement have shown and feedback is taken. Then finally take the model predicted results and compare with actual user feedback using this confusion matrix. These are the evaluation accuracies for each model tested for recommendation system. In the evaluation criteria, RMSE and MAE are better when the values are lower, meanwhile hit rate. Coverage and diversity values should be higher in order to be better. When testing out the model, we asked the participants their comments on the recommendation they received.
From here onwards, I will be discussing the results produced by the models we used in this study. In the attention analysis component, this is how the system presents attention analysis process to the user. Here, the average attention for each minute was calculated and the final attention score generates with an overall final statement for recommending the videos based on attention analysis. Here, in the first graph, it has compared 4 videos by giving final attention ratio score according to the statement. The highly performed statement takes the priority for final score generation. The other graph describes only the medium attention score oscillation based on the video and the viewer. In the emotion analysis, as the final output, an emotion score was generated for each emotion category, specifically happy score, sad score, satisfying score, and neutral score, and send it to the front end. The emotion score was generated by taking the percentage of dividing the number of emotions recorded by total EEG signals recorded. Then at the end of the video, it can be seen with what proportion each emotion occurred during the video runtime. And that final output is displayed in the graph in the right side, while the left side graph illustrates the average emotion prediction scores for the tested users. In the analysis of enjoyment, results have been discussed using accuracy, sensitivity, specificity, precision, and F1 score. It has proven that 90% of accuracy is classifying in low enjoyment, 80% accuracy in neutral enjoyment, and 70% accuracy in high enjoyment. In the recommendation, based on the accuracies generated by the tested recommendation models, we can clearly see that hybrid approach has outperformed the other 3 models, having the lowest RMSE and MAE values as 79% and 65% respectively, and considerable values for hit rate, coverage, and diversity. In this project, there were some professional, legal, and ethical issues to be addressed, and those are listed here. So when gathering data, we exclude anyone having neurological abnormalities and in pregnancy state. And also Muse2 device can be used on individuals above 16 for commercial usage. Therefore, we exclude anyone under the age of 16 when gathering data. These are some of the references we used for this presentation and for this study. And finally, this concludes our presentation about our research study of real-time EEG-based recommender system for video advertisements. Thank you.
Okay, thank you very much for the presentation, and by 4 authors have presented that their research findings, and now I think they are here, right? So, okay, Soumya Bandara is here, and okay, all 3 of them are here. Right, the floor is open for 5 questions. Any questions? Okay, let me start with this manner. So you are trying to detect 3 characteristics, that is the attention, one, and the enjoyment, right? The third one is emotion. Now, so for detecting these 3 categories of information, you are using the EEG signals, and have you used any model, or have you developed any model to detect these 3 categories of things? I think Soumya, your mic is not on. Yes. Oh, hello. Still we cannot hear. Is it my problem or?
No, sir, it is the same for us even. We cannot hear your sound.
Soumya, we cannot hear you. Can someone else answer that? Because her microphone having some kind of problem, I think.
I will answer. Will I answer?
Yeah.
In the emotion and the attention, it's calculated using different models. And when considering the enjoyment, it uses the statistical modeling when an individual the emotion state using empirical rule and the central limit theorem. That are the things we used in the.
Yeah, that's correct. Now, you have you used any already trained model for that one? That's my question. That means that normally with the device also you are getting some kind of emotional state representation. Those type of toy box, some kind of a states models are given. Have you used those models, or have you used some extra?
We created the differently created. Only we gathered the signals wise. That's only getting that signals using numerical values. As physical signals have been used for CSV files, and those CSV files are pre-processed and trained using different models.
So then how did you label them? For example, this is a kind of a happy state, or this is a kind of attention, high level attention state, or so you have to mark it as a ground truth data. Where did you get that ground truth?
When it comes to the enjoyment, we firstly ask the participant to watch a video that is mostly enjoyed, and the data is containing that the enjoyed data. So apart from that, we statistical modeling using that. In the attention and the emotion level, it is also has used same. And apart from that, in the attention, we use markers. If we acknowledge that the user is mostly attentive in that level, we put a marker and select those other highestly most attentive in those cases.
So then the calibration has been used, and after that, have you scaled that data, because the different people get the different signal levels? Now, how did you scale that data, because you are getting millivolt range, right, in the data? So how did you scale it? Or without scaling, have you used it?
We haven't scaled. We use the CSV files and use as the same.
Okay, thank you. So normally, when you are using the data, different people are producing different, the frequencies. Different frequencies are high, and all that differences are available, and that type of scaling has to be done normally. Okay, that is okay.
Yeah,
And
excuse me, sir. For attention part, I have scaled that in the CSS we are going to gather. They are in bells, not in hertz. So we can understand that from previously done researchers, the frequency levels for in attention part, I have taken high level attention, medium level attention, and low level attention. So the detection, for some levels of attention, there are some hertz ranges. Then we can compare those values with that ranges.
Yeah, that's understood. Now, the person to person, these are different, and maybe the same state, maybe the voltages, the values that we are getting are different. So that's what I'm. So my final question is actually now you in the headset. So you have used. Have you used this 64 sensor based one, or maybe if you I think this is not 64 based one what we have shown here, even though there are multiple places you have stored. And you are using only two frontal that just adjacent to the frontal signal, and also you are not using occipital signal. So why you have used only these signal locations or the on the head? Have you considered some kind of factors when you are considering these four signals, the four sensors? Yes. There are four sensors you have marked here. That's what I'm asking.
Yes, with the limitation of the research study, we have used the MOS2 headband. It's only had the four sensors while in the forehead and the behind of the ears, and only we use this MOS2 headband for the situational wise in this study purpose.
Okay, thank you. And so are there any other questions? So seems there are no questions. So let's congratulate this Satsarani and Jailat and Saumya and all the other members of this group for their achievements and their contribution done for this particular publication. So thank you all for your participation and presentation. And let's move to the next presentation now. So next presentation is on the ID 192. That is our fourth presentation. That presentation is titled as Human Tracking and Profiling for Risk Management. This paper will be presented by Vishakha S. Ranjit. He's a fourth year undergraduate at Sri Lanka Institute of Information Technology, and he's following BSc Honours in Information Technology, specializing in software engineering. And he has trained as, he got training as a full stack software developer. His research interest includes within machine learning, deep learning areas. Okay, Ranjit, floor is open for you.
Hello everyone. I am Vishaka S. Ranjit. My paper ID is 192 and corona patients. Hello everyone.
Is there any technical problem, Yashodhara? Yashoda?
Yes, sir. Please give us a few minutes, sir.
Hello everyone. I am Vishaka S. Ranjit. My paper ID is 192. Our topic is human tracking and profiling for risk management. Okay, let me start my presentation.
Not audible.
Before we start my presentation, I will discuss about introduction and why we introduce this system and methodology and key functions. At the finally, we discuss about results and discussion and commercialization and reference. Okay, let's start. Okay, as you see can in this picture, there is an increase in corona deaths and corona patients. So in image proves how the coronavirus, which is now appending in the world, is affecting the human lives. So if the current scenario does not change, institutions and enterprises and companies such as academy, health and key services would suffer greatly as a result of the virus pandemic. So COVID-19 is commonly known as serious acute respiratory syndrome. This is the viral infection that is spread by the respiratory droplets for an infected sick persons who speak or sneeze or cough. Virus transmitted swiftly to the intimate contact with the anybody who is infected or by touching the object or surfaces that have been contaminated with the virus. That's about our introduction. So let's discuss about why we introduce this system. So we know viruses are rapidly spreading to the world. Not only the present, but also Spanish flu, Ebola, and AIDS, SARS, and MERS were once huge global concerns. To defend themselves from this infection, humans employ a number of health practices. However, due to the people's irresponsible behavior, these healthy habits might be lost, and then there is a chance of contracting viruses. So there are some systems were developed to reduce the spreading COVID-19 viruses, like QR scanning systems were developed. QR scanning systems when entering the particular place, etc. So, but our opinion is using this kind of system cannot control the COVID-19 as we expected. So that is why we introduced this system, like which means human tracking and profiling for risk management system. That is why we introduced this system. Okay, this is our methodology. In this methodology diagram, first we can see here is the camera. First we take the CCTV footages from camera, and then these same footages goes through the server, and these same footages go through these four functionality, which is social distance detection and density detection and human behavior recognition and face mask detection. And after detection these features from the CCTV footages, risks should be calculated for each functionality. So if one of the functionality violate the guidelines, this is the take as the risk. Likewise, we take the result of the all of the functionalities and then calculate the risk of the particular time. So after calculating this total risk, if that total risk is greater than 75, we notify the related authorities to take an action. That's our main methodology in our system. Okay, let's move to our key objectives. There is a 4 main key objective in our system. Let's go one by one. First one is social distance risk estimation. So one of the main functionalities in the system is social distance detection. So as we all are known, if we can't keep the 1 meter distance, that will help to the spread viruses. So in this functionality, check whether who is keep 1 meter distance and who is not keep the 1 meter distance. So if someone cannot keep the 1 meter distance, which means if who cannot keep the more than 1 meter distance, it will notify as the dangerous behavior of that person. So that will notify the related authority to get the action. That's about the social distance detection. Okay, let's move to the next functionality. This is density risk estimation. So in this estimation, we all are known, in this pandemic situation, the number of people who can be in the area should be limited. So authorities should be consider the number of people in an area. So in this functionality, count the number of peoples in the particular area, and if that limit exceeds, that area takes as the dangerous area. So that's the main core idea of the density risk detection, right? Okay, let's move to the third functionality in this system. This is a human action recognition, which means human behavior recognition. So human behavior recognition is the third functionality in the system. Although someone keep the previous guidelines like density risk and keeping 1 meter distance between two people, but if someone fails to keep their human behaviors correctly, that will also be the lead to spread the virus. Which means let's assume if someone run everywhere and touching everything, and that is the high risk to spread the virus. So in this functionality, checks the person behaves and recognize the dangerous actions to reduce the risk. So this is about the human behavior recognition, right? Okay, then let's move to the next functionality in this system, which is the last one. This is the face mask recognition. So this is the last function of this system. In this kind of situation, wearing a face mask is a mandatory behavior. So in this functionality, look at whether the people are wearing a face mask or not, and the type of the face mask, like K95, surgical or homemade, that type also we take as the detect. And if someone is not wearing a face mask, and it will take as the risky behavior. So finally, these are our key functionalities in our system, and we mainly hope to this system can be reduce the spreading of virus among people when following these main 4 guidelines. Which means if someone keep the 1 meter distance and not exceed the limit of the number of people in the particular area, and someone if they are keeping the correct behaviors and wearing the face mask, there is a less chance to spread the virus. That is what we focused on that system. Okay, let's move to our results and discussion. Okay, mainly we trained 4 models to 4 functionalities in the system. First one is we trained the model for social distance. We used 500 people images and trained them using YOLO version 3, and we can achieve the 85% of accuracy. And to detect the density risk, we used mobile net for the object detection, and we can achieve the accuracy as the 92%. And to recognize the human actions, we used 400 images, and we trained our model using Keras optimizers, and it can be achieved the 98 of the training and 96 of the test accuracy. So at the finally, we detect the to detect the face mask risk, we use over 200 images, and we use YOLO version 3 for the train our data set, and it can be achieved in the 99% of accuracy. Okay, this is our basic UI in our proposed system. In that system, first we will display the percentage of the risk, and we classify this is place is safe area or danger area or high danger area. Likewise, we categorize this place. So the functionalities now. Okay, let's talk about the commercialization. I will show you a brief video, a short video for you. Okay, that's our commercialization video. Let's go back to our slide. Yeah. Now we saw our commercialization video. Okay, these are our references that we mainly used for create this application. So this is our team. Our supervisor is Dr. Lakmal Rupasinghe, and Ms. Chaitana Lianapatirana is our co-supervisor, and our team is me and Anuj and Lahiru Lakruan and Tilini Radhika. Okay, that's about our presentation. So if you have any question, you can ask now. Thank you.
Okay, I think the recorded presentation we have seen, and Ranjit is available here, right? Hello, Mr. Ranjit.
Yeah, I'm here.
Okay, Ranjit, and so now the floor is open for some questions. If you have any questions, you can raise those questions now. Actually, Ranjit, now according to the human tracking, what your objective is to identify the risk within the society, or maybe within some kind of a premises based on the video analysis. And we have seen that you have used your V3 for your analysis, and you can localize the items as well. For example, the people can be localized, and you can identify people whenever you want to attract them. Now, one thing is you have mentioned there are 5 parameters you are going to measure there, right? In the risk analysis, 5?
No, sir, it's 4 functionalities that we analyze.
Yeah, the distance is one of the function item you are going to check, right? Distance?
Sorry?
Distance, you are
yeah.
Social distancing.
Yeah.
Social distancing, and also face mask also you are going to track, right? And I think in your presentation you have used that numbers, the train, maybe those are videos maybe, right? So video frames, and the numbers you have mentioned are different, and the numbers what you have presented are different. Maybe the 2,000, 3,000, those are there. So when you are measuring the distances, how do you calibrate it, that whether this is 1 meter or 2 meter, because the solid angle to be taken in that situation?
Yeah. Yes, sir. Actually, we use the image pixels to determine what is the distance between two peoples and three peoples.
Yeah, my question is now that is we are working in the 3D environment, and the perspective projection is profiled in the particular image when you are getting into 2D. So when the angles of the cameras are also to be considered, and then when you look at the location, in a particular location, 1 meter is not different. That pixel to the number of pixels to 1 meter, the correspondence is not the same when you look at another place. Have you considered that thing?
Actually, we find some solution for that problem. So the restriction of that in this country, so we cannot find the proper solution for that. Actually, so we assume that we have to place that camera between 10 meters of the distance between 10 meters of the camera and human. So that is how we detect the. That is how we assume the pixels to detect the distance between two people.
Okay. So my other question is, how did you track this? The mask, facial mask.
Sorry.
Facial mask identification. Have you done that one here?
Yeah. Actually, to determine the face mask, actually we determine the category type of the face masks. Actually, it's the homemade face mask or surgical face mask or KN95 face mask. These are the categorization that
what we have saw on your screen actually coming from CCTV cameras, type of things. But how are those cameras powerful enough to give those things?
Yeah, actually these are the powerful enough because these are not a big problem to determine the facial mask.
So within that video is what you have selected, right? So okay. So then, so are there any other questions? So as there are no other questions, so we can conclude this particular presentation also. And let me congratulate Mr. Ranjit and his team for their the experiments and the things they have presented here. So thank you, Ranjit, and let's move to the next presentation. Next move. So next presentation is related to the paper ID 152 that is titled as a rule-based approach for detection and correction of grammar errors in written active voice Sinhala sentences. This will be presented by VP Uresha Sevwandi. She is a final year undergraduate from Department of Interdisciplinary Studies, Faculty of Information Technology, University of Moratuwa. So Sevwandi, the floor is open for you to present your paper.
Hi everyone, I am Uresha Sevwandi, an undergraduate Faculty of Information Technology, University of Moratuwa. My research topic is a role-based approach for detection and correction of grammar errors in written active voice Sinhala sentences. Moving to introduction, Sinhala language is the official language of Sri Lanka and it is the medium of instruction in most private and state schools. The Grade 5 scholarship examination is one and around 76% of candidates face for this exam by Sinhala medium. At the scholarship exam, candidates should write 3 sentences to obtain 6 marks for the compulsory essay question, and it is considerable mark. Then we have to clarify why we are targeting this essay question, because each year approximately 83% of students obtain 0 marks at the exam. When examining the marking rubric of the essay type question, Clearly, a great percentage has allocated to the accuracy of grammar. Furthermore, grade 5 students should have proper practice with essay writing to face the essay question well, avoiding common mistakes. Moving to problem in brief, we have identified common mistakes done by the candidates during the exam, such as confusing sentences, spelling errors, grammar errors, repetition errors, and colloquial language use. Traditionally, students too much depend on their teachers to correct written essays and do not have opportunity to self-learning and self-evaluating their essays. Moreover, lack of tools available to detect Sinhala grammar errors and provide suggestions for incorrect grammar in typed sentences for primary students to improve their usage of accurate Sinhala grammar. Further, this grammar module has designed as a part of grade 5 essay marking system. Then let's see how we can address this problem. We have designed our grammar module under two major components such as grammar error detection and grammar error correction. The grammar error detection consists of error type identification and assign final grammar module mark. Then the grammar error correction component will provide suggestions. My paper describes what are the current research available and what are the drawbacks of each and every item, and commonly I can say these are major drawbacks of those studies which are not touch up to the level required Sinhala grammar. The objectives of this proposed system you can identify as detect grammatical errors within a defined scope in given Sinhala sentences, identify error type of detected grammatical errors, provide suggestions to correct identified grammatical errors, assign mark for an essay considering grammar, and develop a web-based application which users are able to input their Sinhala sentences. Moving to grammar error detection and correction module, here consider only active voice sentences, present and past as tense-wise, singular and plural as number-wise, masculine and feminine as gender-wise, indeterminate category, first person, second person, third person under person category. The input of grammar module is spell correct post-tag sentences. The process consists of pre-processing, grammar error detection, error type identification, give suggestions for grammatically incorrect sentences, and allocate final grammar module mark. To implement this, I have chosen a rule-based approach because our system has implemented for Sinhala language and Sinhala has clearly defined set of rules. This is easy to understand. Rule-based system is more transparent and errors are easy to debug, like easy to add, remove or edit, and accuracy able to improve addressing more rules. Moving to high-level flowchart of the grammar module, you can see grammar error detection has implemented with the set of rules matching with database, and grammar suggestion module use both database and corpus along with the rules. This is the detailed diagram of the grammar module. Moving forward, at the pre-processing, the input is spell correct post-tag sentences, and sentence tokenization, word tokenization, and subject identification happen here. This is an example for addressing free word order problem, and you can see the system generated output like this. This is also system generated output for free word order problem. Grammar error detection happen under three main processes such as subject pattern identification and verb pattern identification. Moving to subject pattern identification, only identify a subject in a sentence is not enough to check a sentence against Sinhala grammar because depends on subject pattern, the predicate will change. For a user enters sentence, first check whether a Samohavachi word like Rala, Pella, Mula, Kala, Ranchua, Pirisa is available in this user input sentence, because depends on the previous word of Samuhavachi word, the predicate will change as singular and plural wise. This previous word may be an animate or inanimate one, and according to that subject pattern we'll able to decide. For examples, when we take in sentence as Tarupela ahase babalai, here the word before Samuhavachi is Taru, and that is inanimate one, and the subject pattern able to identify as inanimate singular without edit. If we take a sentence as Samay pela pasal yati, the word before Samuhavachi is taken as lamai, and that is animate one, and according to that subject pattern able to identify as subject masculine plural without edit. There is no Samuhavachi words available. Next, we are able to check with Ho rule identification. Here, every noun should consist with Ho prepositions to check this rule. Depends on the word before last Ho preposition, the subject pattern able to identify. For examples, mama ho, piya ho, gedarayai. Here, the word before last ho is piya, and according to that system, will identify the subject pattern as subject masculine singular without edit. And taking a sentence like piya ho, mama ho, gedarayami, the word before last ho is mama, and according to the system able to identify subject pattern like subject first person singular without edit. If this both Samuhavachi or ho preposition not available in user input sentence, then able system will check against Nitya Bahuvachana rule under singular and plural aspects. Taking an example like ek I kratayai, this belong to singular category because ek word available here, and system able to identify subject pattern of this sentence like exact singular without edit. And taking a sentence like I kratayati, system able to identify here subject pattern like exact plural without edit. Moving forward, the system checks all the sentences against all person types and Gauravartha pada, as person types checks for first person, second person, and third person. For examples, checking sentence as Mama Gedarayami, system able to identify its subject's pattern like subject first person singular without edit, like Api Gedarayamo, system able to identify subject first person plural without edit as its subject pattern. When taking a sentence like Tata Gedarayai, system able to identify its subject patterns like subject masculine singular without edit. And taking a sentence as Piano Daruan Poshane Karati, system able to identify its subject pattern like Gauravartha. When user input sentences consist with prepositions like the, here, first person singular subject and any person type subject able to create first person plural verb. If the user input sentence like Mamad Ammad Gedara Yamu, our system able to identify subject first person plural without edit as its subject pattern, and second person singular subject and third person singular subject able to create second person plural verb. According to that, if the user input sentence like Numbai Ammai Gedara Giyev kind of, our system able to identify its subject patterns like subject second person plural without edit. When comes only third person subjects along with the preposition, predicate will be in third person plural form. Like if the user input sentence Amma Tatat Polatayati, its subject pattern able to identify as subject feminine plural without edit. Then if we are still unable to find a subject pattern, remove common errors and take them to decide subject pattern. For an example, when user type misspelled word within a sentence which belong to common error table at the database and received it as a spell correct word, Ranaviruwa Radabera Ganimati Idripat way. Here Ranaviruwa is wrong spell word, that is not include our corpus, but this is grammatically correct sentence. Therefore, take it as spell correct word and able to decide the subject pattern also here. Still, if we are unable to find a subject pattern, then check for availability of innominate word. Based on that, predicate able to decide. Here, both singular and plural innominate words have singular predicate. For examples, when taking a sentence like Udasana Suwandamal Pipe, here mal is plural and that is inanimate. According to that, our system identifies subject pattern like inanimate plural without edit. Taking the sentence like Ratri Ahase Sandapabala, here Sanda is singular and that is inanimate. According to that, system identified subject pattern is inanimate singular without edit. Still, if unable to find a subject pattern, then check at least object available at the sentence, and according to that, able to decide the subject pattern. If user enter a sentence like "Apa වැඩිහිටියන්ට සැලකිය යුතුය," here subject pattern able to identify as object, then up to this level subject pattern identification has done. But if still not cover any sentence using above rules, output will be the because we checked all possibilities for grade 5 students within the scope to identify the subject pattern well. Then identify the word before full stop when having multiple sentences or last word in the sentence when having a single sentence, and consider that word as the verb or predicate of the sentence. After that, match previously identified subject pattern along with the verb ending patterns at the database. If the basic subject and verb matching okay, then move to internal grammar rules. Here, first check for preposition rule against both preposition subject category and object category. Moving to preposition object category, our system able to identify sentences like Gehelio Malcolmen Karunika Veti. Moving to preposition subject category, our system able to identify Malli Vanahi Mavagi Ekwa Puthuwei kind of sentences. If the user enter a sentence like Balan Buradi Sorupalai Hati, our system able to identify this along with Asambhava Kriya rule. If both preposition and Asambhava Kriya rules are okay, then check for tense. If a sentence consists with words like Iye, Eda, Pereda, predicate will be in past tense and tense will also check under selected topic. This is an example for system-generated output for an essay under a selected topic. After clicks on Tahawuru Karanna button, you can see the system has identified these sentences as grammatically correct. Moving to error type identification, our system able to identify 4 error types such as Uktakyata Nogalape, preposition error, Asambhava Kriya, and tense error. These are examples for system-generated output when user input grammatically incorrect sentences. You can see identified error type and based on that provided suggestions here. According to identified subject pattern, give suggestions for both directions, only for first person, second person, and Nitya Bahuvachana sentences. Other than for subject to verb direction, our system able to provide suggestions. This is the flowchart for grammar suggestion module. In this slide, you can identify how our system suggests predicate according to identify subject patterns. These are system-generated suggestions for grammatically incorrect sentences. In this slide, you are visible how our system identifies grammatically incorrect sentences, their error type, and system-generated suggestions. We have evaluated this grammar module under grammar error detection, error type identification, and provide suggestion aspects. In the proposed system, when using sentences with words only belong to the corpus and within the defined scope, the grammar detection accuracy is 100%. Error type identification accuracy is 93% and suggestion module accuracy is 83%. Moving to conclusion, Sinhala has a lot of grammar rules and it is very complex. The proposed grammar module was able to cover pre-word order problem within the scope successfully. Complex grammar rules and novelties like indeterminate, Gauravartha, Nitya Bahuvachana, Samuhavachi Pada, preposition categories, and Asambhava Kriya also able to cover within this grammar module. In future, supposed to conduct grammar checking for passive voice sentences and address free word order problem more widely. the accuracy of rule-based approach able to further increase by defining more grammar rules and increase the word content at the corpus. Instead of using a role-based approach, move to a hybrid approach also another direction. Not only that, able to widely address this error types identification and suggestions for both subject and verb directions, also able to identify as future works. This is the references list. And thank you.
Are there any questions?
Hi, I'm Kasun from UCSC. Thank you for your interesting presentation. I just would like to know, in a practical scenario, if you are using data sets from different disciplines. So let's assume that this is data, there is a essay written related to medical field or computer science field or something in Sinhala. So will there be some kind of accuracy drop or anything? So I mean, how you can explain, how you can elaborate this application of this research into practical scenarios?
Uresha, I think your mic is muted. Can you switch on your mic and answer the question?
Sorry. Now I think I can. You can hear me.
We can hear you. Yeah.
Okay. Actually, our data set has designed fit for our target audience, that is for grade 5 students. So we collected those data from visiting schools and collected essays and get the support from teachers and referring the teacher's guidebook as well. So we in that situation, we get this accuracy. So we can enhance this data set and add in your requested field data. So we can actually achieve somewhat level accuracy there.
Okay, Uresha, so that means like you want to train your algorithm, like train your model with the enhanced before application, right? Into a real world scenario.
Yes, we have to improve that level.
Okay, good. Thank you. Nice research.
Thank you very much.
So
you have used a rule-based method.
Yeah,
is there
I
possible
have.
to use automated thing like some of the BERT or sequence modeling technique used in neural network?
Yes.
Do you think it's possible to get a better result?
Actually, in this aspects, according to our target audience, that rule-based approach is actually we could get a best result. In future works, we try to, along with machine learning, move into hybrid approach. That's my plan. Because I saw some UCSC research, there was a neural network approach, we get 60% accuracy at there. So they suggested, according to the literature review, I identified, they suggested moving to the machine learning technique along with this rule-based approach. So after combining those two things, I think we can get more accuracy using hybrid approach there.
So any other questions? So, okay, let me thank the presenter, the Uresha Sevgandhi, for her presentation and participation for this particular session. So so let's congratulate her and her research team as well. And so this is the end of the session, and we have had 5 presentations today. And so over to you, Yashoda, for the concluding remarks.
Thank you very much, Session Chair Dr. Ranatunga, for leading this session, and the authors who have presented their papers, and all the other participants. Now we can move on to the next item in our agenda. Next we have this keynote speech on making smart cities more playable by Professor Anthony Holt. So for that, I invite all of you to join the main session of this meeting. That concludes session 4A of ICTA 2021. Thank you very much.